In 2017, on May 16, a brutal murder was reported in Tilak Nagar, which left the police clueless. A 57-year-old woman was murdered in her house, and the valuables from the house were missing. It was reported that her son was sleeping in the other room when the murder happened. The victim's son found her lying dead on the floor of her room the next morning. What was the motive behind this murder? Was it a robbery? Who was involved? Unsolved. The case was handed over to Ms. Suganti Ravi, Deputy Commissioner of Police.
We received a phone call around 9 in the morning. It was a man who was trying to inform the operator regarding the murder in Tilak Nagar district. His voice was cracking as he tried to form sentences. Our police force rushed to the crime scene immediately, and a dead body was found in the bedroom. It was a 57-year-old woman with strangulation marks on her neck. The man who informed us was the victim's son. When we questioned him, he said he was sleeping in his room and didn't hear anything. He found his mother lying dead on the floor when he woke up in the morning. We obtained the murder weapon, a 1-meter phone cable, and seized the victim's belongings as well as the necklace, which she was clutching in a tight grip. We confirmed that the cable was used to kill her. The forensic team came in to sort for any trace evidence. We were informed by the son that some expensive jewelry and a vast amount of money were missing. Our inspector proceeded to question their neighbor. As this incident happened around 3 in the morning, no one heard anything. Without a witness or proper evidence, we were unable to identify the murderer.
While all the traditional methods of police failed, the forensic team was analyzing the evidence obtained. According to Ms. Yugita Alphonse, the head of the forensic department, this was a difficult case to handle since there weren't many traces left behind.
I have been working in this department for more than 10 years. This case caught my interest. There were few traces of evidence to the crime scene, and we managed to retrieve a 1-meter phone cable that was used to strangle the victim. We could not identify any fingerprints, hair samples, blood samples, or body fluid of the convict from the crime scene. The post-mortem revealed that she had died from strangulation, and signs of struggle appeared where bits of the cable jacket were found under her fingertip. We lacked much solid evidence to identify the perpetrator responsible. Then, we had our forensic science laboratory experts to conduct chemical analysis and high-intensity X-ray at the crime scene to obtain any clues or traces left behind by the convict that was overlooked. From these analyses, we swabbed bacteria and fungus at the victim's window.
Then, this case was investigated by Ms. Vaishnavi Murugesu from the Microbiology department.
As a microbiologist, we study various microscopic organisms such as viruses, bacteria, fungi, and algae. Not only that, but we also assist other major industries such as forensic, food, medicine, and cosmetics as we did in this murder case. For me, this is one of the most interesting cases as my team worked together with the police to solve a real-life murder. After receiving the chemical analysis report from the forensic department, I proceeded with the identification of the unknown microbial community that was swabbed by the forensic team. So after cultivating the sample, the organisms were observed. I discovered that the microbial community observed was commonly found in garbage cans and dump-yards. Gram-positive cocci and Enterobacteriaceae, which belong to the bacteria domain such as Staphylococcus aureus, E. coli, Listeria, Salmonella, and Klebsiella are some of the most prevalent bacteria identified in dump sites. And the case was finally back on track.
This brought a new perspective to the case, which aided the continuation of the crime investigation.
We suspected rag pickers, laborers, and beggars from the information passed over by the microbiologists. We went through the surveillance cameras again and identified a few suspicious personnel from the targeted group. They were investigated and a 19-year-old boy was arrested. He found 900 grams of gold worth 28 lakh Indian rupees in his possession. The perpetrator was charged and brought to court.
New science is finding that each one of us brings with us and can't help but leave behind a unique bacterial signature everywhere we go. As you move through a scene and shed your microbes, the space starts to reflect your bacterial signature, potentially tying you to it and giving away a lot about you in the process. To test how much bacteria gets left behind and what it can reveal about your identity, scientists will compare the swabs collected from the robbers and see if they can differentiate them from those of the homeowners. They'll also try to see if they can tease out the signatures from the samples from the scene. If they can, it will provide early proof that an outsider's bacteria is distinct enough from the homeowners to confirm that a stranger was in the house.
One main use in forensic microbiology is used to identify the recent environment of the victims, their diet, or even to link them back to other individuals. It is also to determine a microbial signature for an agent. Other than that, it includes the deaths that occur in less ideal conditions, such as extreme cold and heat. This is also to determine the time of death from around 2 to 4 days and up to 25 days. The location-based information of a person is determined by their microbial forensic. Lastly, forensic microbiology can be used to interpret cases of infectious diseases that result in sudden death.
Microbial fingerprinting techniques distinguish microorganisms or groups of microbes based on the distinctive properties from a segment of a biomolecule such as phospholipids, deoxyribonucleic acid which is DNA, or ribonucleic acid which is RNA. Some microbial fingerprinting methods provide information on subsets of the microorganisms present, while others provide an overall picture of the microbial community. There are several methods in microbiome fingerprinting, such as phospholipids fatty acid analysis, denaturing gradient gel electrophoresis, and terminal restriction fragment length polymorphism. These microbial fingerprinting methods, such as tracking of fecal microorganisms, aid in the identification and tracking of microbes related to the chemical compounds originating from industrial or energy-related activities. For instance, in an investigation of a crime, microbiomes such as bacteria, fungi, or viruses found at the crime scene may be linked with the perpetrator who came in contact with them. This serves as a trace evidence for forensic identification, which detects the gender, weight, ethnicity, and smoking or drinking habits of the perpetrator. These leads could be a useful key to the police. Additionally, the microbiota left behind by a suspect on a victim could be used to link the specific body region of the assaulter in a sexual assault case.
As a piece of major evidence, skin plays an important role as the main subject for microbial identification. Microbiota on the skin is an important piece of evidence that aids in the investigation as it traces the bacterial cells found on human skin. Skin microbial signatures can be identified through swabs of surfaces touched by a suspect. The result from swabs mostly varies depending on the surface's swab. Frequent contact on the same surface is able to give a better result. The skin microbiome signature lasts for about a day. Some of the common bacterial species related to skin, such as Staphylococcus species, are significantly abundant in residential homes of investigation. Another sample of microbial fingerprinting detection in crime inquiry is shoes and cell phones. Since shoes and cell phones are often used by almost every human being, it could be a huge lead to the identification of the perpetrator. A swab from the surface of the cell phone or trace of a footprint will be tested using one of the methods listed previously and can be identified by the similarities of the microbe's trace, which match the suspect or location of the crime investigation. Climate, altitude, and rainfall influence the microbiome communities in different parts of the world, thus aiding in the identification of certain geographical locations of the crime situation. As a result, microbial fingerprinting techniques can provide a comprehensive picture of the microbial community.
A bacterial signature has many advantages over diagnostic DNA evidence. Microbes are abundant in crime scenes, so it is more convenient to recover bacterial DNA than human DNA for forensic identification. This is due to the difficulty in obtaining human DNA if the suspect does not leave behind blood, semen, tissue, saliva, or hair. Bacterial DNA can be recovered easily compared to human DNA from contact surfaces because bacterial DNAs are more widely available in most scenarios than human DNAs. The post-mortem interval can be measured via the migration of microbial microorganisms from the crime scene into the sterile organs such as the liver, spleen, heart, and brain. It is because our immune system avoids microorganisms from getting into these organs when a person is still alive. Therefore, the microorganisms tend to spread into these organs after death. There are also some disadvantages of forensic microbiology. One of the drawbacks of bacterial signatures is a corresponding change in the microbiome because of cosmetics, dietary changes, antibiotics usage, and health states. Our microbiome is distinctive because it is partly determined by our immune system and genome. Hence, it is more difficult to use these signatures to identify a person beyond any reasonable doubt as human DNA evidence can. Different populations of microorganisms could be identified for every individual that comes in during the investigation and evidence search, which makes the scale to find the suspect larger. The assembly of microbiomes could still serve as possible trace evidence.
The law and policy regarding the usage of microorganisms as evidence could be further developed in the coming future as it is currently in the early stage of advancement. Microbes have shown potential in aiding crime investigation and could be used as valuable information in forensic applications together with the integration of traditional methods. Skin microbes could be used to expand the scope and power of trace evidence analysis. Trace evidence refers to minute evidence such as hair, fingerprint, fiber, or soil. Due to the genetic and taxonomic signatures, bacterial cells have a higher resistance to decomposition and degradation by the environment. Therefore, the bacterial cells found in crime scenes are more lasting when compared to residual human biological material, which is usually used as evidence. Thus, it is a necessity for crime scene individuals to protect a crime scene from contamination by those who enter the scene after the occurrence of the crime.
Back on track.
Super je. The victim's window.
Bersama.
Yeah.